In our last example, we graphed a function. Let's now take another look at that function and let's just do some quick computations with it. So again, our function is f at x is 2 if x is less than or equal to 0, and it's x plus 1 if x is greater than 0. So I have a number of computations. First of all, I'd like to evaluate f evaluated at -4. So remember that to compute something like f at -4, we recognize x would have to be -4. And so we then take that information and we look back up at our function and we say, okay, this is when x is -4. Which of those two lines does that go into? And if I think of this as line 1 and line 2, then what's going to happen is I'm going to substitute the x equals -4 into line 1. Well, remember from our function with line 1 that it doesn't matter what x we use, as long as it's in the domain, we'll always get out the value of 2. So f at -4 is 2. Let's take a look at part B. Evaluate f at 0. This is the trickiest of the three because 0 is the breaking point between the two pieces. But remember, in our two pieces, that it's the first one that actually allows us to use x equal to 0. So again, f at 0 means we're using x equals 0. Again, that's in the domain of the first piece. The first piece tells us it doesn't matter what x we use, as long as it's a valid piece, we always get out y equals 2. So what we learn is f at 0 is equal to 2. So let's take a look at a third example. Evaluate f at 5. So now, f at 5, again, with that 5 inside the parentheses, we recognize that x equals 5. If we looked back up at our function, we would notice that in this case that's piece 2. And so it's in the domain of the second piece. And remember, piece 2 would have been f at x is x plus 1. So our x is 5, so we get 5 plus 1, so we get 6. So f at 5 is 6.